Shall we start now, sir?
Ma'am, there are no participants, right?
It's one-side presentation, sir. Most of the participants will be join our live webinar, sir, on YouTube channel and Facebook, sir.
Okay, okay.
Hello, everyone. Present here virtually. I am Nita here, and I welcome to you all for today's session, which is the title as Infant Spectroscopy, a growing innovative research field for agriculture. And presenting this session, we have with us our today's expert, Dr. Agnibhadas Mujumdar. Dr. Agnibhadas Mujumdar is currently working as a assistant professor, Department of Physics. Institute of Technology and Science, Madanpalli, Andhra Pradesh. He has a completed PhD thesis in physics with 3+ year of experience as a research scholar and expertise in working on experimental biochemistry, food technology, and food physics, theoretical numerical model using mathematical simulation and modeling as an independent researcher. You may start now, sir.
Okay. So, very good morning to all the attendees and participants. Great introduction. So today's webinar is on a topic that is infrared spectroscopy, a growing innovative research field for agriculture. So this lecture is important for the people who are very much interested in the agriculture field, because nowadays our daily life is very much independent. Very much dependent on the agricultural products. So we can say all the food products they are taking, and so those are from the agriculture only. So agriculture is a very emerging field nowadays. Not nowadays, from the last number of decades, agriculture is very much important field for our daily life. So now coming to the research part, that is
Sorry to interrupt you, but sir, your PPT is not visible. Sir, can you please share once again?
Okay, okay. Now is it visible?
No, sir.
Is it visible, ma'am?
No, sir.
Actually, I have already. Huh?
No,
No?
not visible, sir.
I've already shared. I don't know why. It's sharing from my side. I don't know why it is not.
Okay, sir, then you can start, sir.
Is it not? It is not visible, no?
Yes, sir, not visible. PPT is not.
Actually, I have already shared from my side. I don't know why it is not. Because I have shared multiple times. But it is showing in the app that it is sharing.
Yeah, it's showing started screen sharing only.
So you can see my sponsor.
Yeah, there will be written Agnibha Das Mazumdar has started screen sharing. Yeah, written like this, but we don't see your PPT, sir.
Give me 2 minutes this time.
Okay, sir. Yeah, now it's visible, sir.
But now I didn't share it.
Yeah, it's visible, sir. Now you can continue.
Okay, okay.
Thank you.
Okay, so so sorry for the interruption. Some technical issue was there. So as I was telling you that the coming to the research part, that is infrared spectroscopy. So spectroscopy we will know about spectroscopy in my next slides. So the term infrared spectroscopy is nowadays very much growing research field. So with which we can maintain the quality of the agricultural products. So as the agricultural products are somehow related to our food, so food is related to our health as well. So to maintain our health, it is very much important to maintain the different quality parameters of the food products. So if we want to maintain the quality of the food products in a scientific manner, we need to have this application, which is known as infrared spectroscopy, which I have mentioned. So the title stands for infrared spectroscopy, a growing innovative research field for the agriculture. Okay, so let's start with the topic. So before that, as also ma'am has said that I am Dr. Agnibha Das Manjumdar. I am an assistant professor in Department of Physics in Madanapalle Institute of Technology and Science in Andhra Pradesh. Okay, so now I have told you earlier the infrared spectroscopy. So for that we need to know about that what is the infrared spectroscopy and from which area of science it can be concluded, or this term came. So now the infrared spectroscopy comes from a electromagnetic spectrum. Now we can say what is electromagnetic spectrum. So if the term infrared spectroscopy comes, automatically the source of infrared spectroscopy comes from the electromagnetic spectrum. So now the electromagnetic spectrum, we can have this spectrum from our natural resource. What is the natural resource? The natural resource of the electromagnetic spectrum is sun. So you can see this is a sun. So sun is radiated the light that is known as electromagnetic spectrum. So that electromagnetic spectrum is having different ranges. That ranges I'm explaining from this slide. Okay. So what are the different ranges present in electromagnetic spectrum? There are 6 different ranges. What are those? First is the X-ray. So we all know about the X-ray, that if we are having some fractures or we are having some cough or cold, so doctor prescribed us to do the X-ray. So because this X-ray is having some small wavelength, so it can obtain the information of our bones very easily. Okay, so the X-ray itself comes from the electromagnetic spectrum. Now the ultraviolet rays. Nowadays we are very much conscious about our skin and all. So what does we just you might have an idea about that sunscreen. So in sunscreen, they have mentioned that is a UV protected cream, UV protected cream. So that term always comes. So UV ray that also comes from the sunlight, and it is a part of electromagnetic spectrum. And it is very harmful for our skin as well. So we are using some that is specs. Those are UV protected specs. Okay. Now the next, that is visible spectrum. Visible spectrum. So we all are seeing the visible spectrum. So if we can see each other. So if I'm seeing on that laptop, I'm watching the laptop. I'm delivering the lecture. So if the laptop and the laptop screen, I can see. How I can see this? A light comes from a source. It will falls down on the laptop screen and it will reflect it back. What kind of light it is? These are the visible lights. So that is a very basic things. And we all know what are the different colors of the visible light. That is Vibgyor. What is Vibgyor? So violet, indigo, blue, green, yellow, orange, and red. That is the Vibgyor. So Vibgyor is a part of visible spectrum. Now that spectrum, so you can see from that visible spectrum, the ultimate color is the red. Okay. So in the year of 1800, Sir William Herschel, one scientist, he invented one particular region of the electromagnetic spectrum, and he got that spectrum beyond the red region of the Vibgyor or the visible spectrum. So Okay, so in the year of 1800, Sir William Herschel has invented one region, and he got that region beyond the red region of the Vibgyor. Okay, so that is why we call that region is infrared. Infra means what? Infra means beyond. So got region beyond the infrared, beyond the red. So that region is known as itself infrared region. Again, after that, one is microwave region. So this kind of radiations we are using in our microwave oven. So the heat molecules are there. Sorry, so the food molecules are there, and that microwaves are coming, and what it vibrate with that molecules, and it will be generating some energy in terms of heat. So we can have the that warm food at the time of lunch or dinner or breakfast. And the final region, that is what? Radio region. So that radio region is very much important for the our telecommunication system or any communication system. So our communication system is based on the radio waves. Okay. So among all the regions, we are focusing on the particular this topic or particular for this research. We are focusing on the what region? That is infrared region. That I have already told you that why infrared region are there, and what is the source of infrared region, who invented the infrared region, that all I have told you. Okay, so the range of the infrared region is from 25 micrometer to 2.5 micrometer. So that is a range, and it is having three different subregions. One is far infrared region, another one is mid infrared region, and the final one is near infrared region. So those regions are having different energy values and the different wavelength ranges. Okay, okay. Now coming to the next. Okay, so let's start with a brief introduction about the spectroscopy. Now, spectroscopy is having, so before starting the spectroscopy, we are having three important points. One is demand for product quality improvement, and second one is need of a rapid, non-destructive, reliable technique, and third one is the emphasis on the food safety. So as I have told you earlier, there is a demand for the product quality improvement. So if the agricultural products are there, and those agricultural products are somehow related to the mankind, somehow related to our civilization, so we need to maintain the product quality. We need to improve the product quality. We need to maintain those quality. So for those, we need infrared spectroscopy. Another one, second point, that is a need of rapid, non-destructive, reliable technique. So what is a rapid technique? So we all are going behind the time saving. So the infrared spectroscopy is a time saving method. It is not time consuming method. It is a time saving method. So with this method, rapidly we can check the quality parameters of the agricultural products. Also non-destructive method. We are not using any kind of chemical, harmful chemicals or hazardous chemicals which are not eco-friendly. So nowadays, we all are going behind the green methods. If you all are from the chemistry or the pharmaceutical background, you should know that we all are going behind the green methods. We all are going behind the eco-friendly methods. Why? Because nowadays we need to save our nature. We need not to produce any chemical hazardous, any chemical garbage to our nature. So that we all need that non-destructive reliability. So that non-destructive and rapid reliable technique we can get from the infrared spectroscopy. The final point is the emphasis on the food safety. So if the food quality will be maintained by this technique or this technology, automatically the food safety comes. So we need to maintain our food safety as well as with the food quality. Okay, so that is the need or importance of the infrared spectroscopic technology or technique. So that I have told you earlier, that is basically a pictorial presentation of the sun. The sun is radiating the infrared spectrum. So this is the different regions of the infrared spectrum, which I have explained in the last slide. Okay. Now come to the near infrared spectroscopy. So in the infrared spectroscopy, that particular region, that is near infrared spectroscopy, is very much important for the agricultural products. Now, what is spectroscopy? So you can see the term spectra is having a place in the spectroscopy. So spectra, what is spectra? Spectra is a electromagnetic radiation. So if there is an interaction between any electromagnetic radiation with any kind of matter, any kind of material, the spectroscopy comes. Okay. So near infrared spectroscopy, that region is having a wavelength range from 800 nanometers to the 12 to 2500 nanometers. And it also can penetrate much farther into a sample. Why this is important? So why you have taken in IR spectroscopy? Why not MIR, that infrared or far infrared? Because NIR spectra can penetrate much farther into a sample other than other radiations. Now this spectroscopy based on a molecule, this spectroscopy, that principle of the spectroscopy is having a basic idea of the molecular overtone and combination vibrations. Also I will discuss in later. So this spectroscopy used for the qualitative as well as quantitative measurement of organic functional groups. It is not applicable for the inorganic functional groups. So what kind of molecules? That OH, NH, C double bond. So these molecules are IR active molecules. Why? Because those vibrates with the IR radiations. Again. So what is that? How near infrared spectroscopy works? So in the short term, we can say the working principle of the near infrared spectroscopy. So as I told you, there is a interaction taking place between the light energy in terms of spectra and the matter. So after the interaction, absorbance at the resonant frequency associated with atomic and molecular vibration. Now you can ask, what is the resonant frequency? I have the answer. Resonant frequency means the molecules in the, so we know when molecules are vibrating, here you can see some pictures, the molecules are vibrating with each other. One is symmetric stretching, another one is asymmetric stretching. So in symmetric, they are in a same phase. So they are vibrating in a same phase. But in asymmetric stretching, they are not vibrating in a same phase. They are having a different phase of the vibration. So in the initial stage, those molecules are having some energy. Why? Because we know the energy value E equals to half h nu. So it is having some minimum energy. And after the radiation comes or falls on the matter, the molecules vibrate with a more energy because it absorbs some energy. When it will absorb, the energy of that particular vibration. Okay, so that point is very much important and we need to understand. When it will absorb, The light radiation comes from the source and falls on the matter. Molecules are present in the matter and it is having some latent energy with it. So with that energy, it is vibrating. Now, the radiation, IR radiation comes and falls on it. Whenever the energy of that IR radiation, that IR radiation is also having some energy. Whenever that energy of that IR radiation and the vibrational energy of the molecules match, that frequency is known as resonance. And at that resonance frequency, that molecule can absorb the IR radiation and it will having some more energy, some transition will take place. Some transition will be taking some place. So what kind of absorption, what kind of molecules can absorb the IR spectrum? That is CH molecules, that is NH molecules, that are SH molecules, and the OH molecules. So basically, the hydride molecules can absorb the NIR. Now, coming to the next. I have told you about the vibrations, and I have made one slide for that. Visualize the bonds between the atoms as a spring. So just let's suppose we are having a spring and two balls attached different sides of that spring. So the classical physics considered the atoms as a particles with a given mass. So these are two okay. So these such a let me just okay. So there are two different balls or different atoms which are having different mass. That is M1 and let's see that is M2. Okay, this is the spring. This is the spring and it is vibrating with a line axis spring. So now the bond length is equilibrium. Bond length is equilibrium. This is case 1. That is case 2. That is case 1. So if we apply some spring force over there, so a stretching will be taking place and again a compression also will be there. So that is a mechanical model of vibrating diatomic molecules. Okay. And is my screen visible?
No, sir.
It was visible earlier, no? Okay. Okay, coming to the next slide. Okay, so these are some mode of propagation. So what I have told you earlier, there are some interaction are taking place. So now, what kind of interaction will be there? What kind of propagation of light will be there? So here is the three things. First is the transmittance. So what is the transmittance? Light comes from the source and it will detect from the matter or detect from the that material, detect through that material, transmit through the material. That is transmittance. What are the second part? That is reflectance. So it will not transmit through the sample, it will reflect it back after taking the information from the surface of that particular sample. Now, what is the third thing? The third is the transflectance. So what is the transflectance? The light or a radiation comes from the source and it will go through the sample, but it will not transmit to the other side. It will reflect it back from the inner surface of that sample and comes. These are some three modes of propagations. Now, near-infrared interaction with matter that already I have discussed. So, no need to discuss again. Now, this is a particular database which I have collected from the Scopus. This is the recent data. So, what is that? We have collected the number of articles in the y-axis and the x-axis. So here we can see many research has been done NIR spectroscopy and about the mango. So in food products, I have particularly select one fruit, that is mango. So in the second, we can see there is a very few research on the near infrared spectroscopy, non-destructive technique and man. In the last, we can see there are very much small research has been done on the keywords, that is mango, NIR and India. So in India, that field is a growing field. That field is an emerging field. So number of work can be done within the India for the agricultural development with the near infrared spectroscope. Now instrumentation. So this is a near infrared spectrometer which I have taken from my research lab as well. So we can use this near infrared spectrometer for the analysis of any food products. Here, this picture itself shown is a, just let me see, let me show. Here, this is a mango pulp. This is a mango pulp. So I have used the mango pulp for the quality analysis. And this picture I have taken from my research lab as well. The second, that is how the infrared spectra we can collect. So here, source is there. After that, one collimating lens is there. So that lens focused that particular light from the source. After that, that light passes through the filters. So we are using the filters of the 750 nanometer to 2500 nanometer, as this is having a infrared region. After that, the sample holder will be there, and after transmission or reflectance or the transflectance, after that three phenomena, we can have the data which will be detected by the detectors. And after that, one oscilloscope will be there in the system. We can have the spectral graph that I will show you later. Some spectral graph will be there. From that graph, we can conclude the information about, or qualitative information about that particular food sample. Now, details of the each block. So, number of blocks, source is there, filters are there, sample holder, detectors, oscilloscopes are there. So now we will study each and every sector in details. So first, what will be there? Source. So in source of the radiation of IR spectrum, we can use halogen tungsten lamp or some LED lamps which are having 780 to 2500 nanometer wavelength. Dispersing element. So for the dispersing element, we have used, I have shown you the filters. So not only filters, we can use the gratings, we can use diffraction gratings, we can use the monochromators, also we can use filters. Sample holders. So there are a number of samples, like we are having the powder sample in the solid, we are having some gaseous sample, we are having some liquid samples. So in my research lab, basically I am dealing with the liquid samples. So I have used these quartz cuvette. So that cuvette is very much important, or cuvette is very much applicable for the liquid samples. So I have used that cuvette and the dish sample and the liquid sample holders. So liquid sample holders or quartz cuvette are also same. And for the powder sample or solid sample, we can use dish sample holder. Now, getting the data from the sample, we have to detect those sample and we have to send to the oscilloscope for the graphical representation. So in the photodetectors, we can have some detecting material, that is silicon, indium gallium arsenide, and PBS detectors, which converts the light signals to a voltage or current. Okay. Now coming to the part that is application of IR spectroscopy. So it is having a ample application, as we can see. We can calculate the qualitative parameters of the grains and cereals, legumes, beverages, poultry and beef products, fruits, vegetables, pharmaceutical products, and the oil industry. So these all things are somehow related to the agriculture. So agricultural field, the quality maintained of the agricultural field is very much dependent on the near infrared spectroscopy. In agriculture, near infrared spectroscopy using data collected by the scanners and imaging provides the non-destructive and the accurate sensory and internal quality parameter analysis. The real-time analysis. So what is the real-time analysis? Which we are doing now, that in real life. So real-time analysis, this research is very much important for the real-time analysis. On-site enabled by newer scanner-based portable devices. So we can make some portable device with the help of that near infrared spectroscopy. And also we can take in our pocket, we can go to market with that portable device easily. Like if this is a mobile phone, let's suppose this is a portable device. So this is the mobile phone. Let's suppose this is a portable device and it is a cup, and we need to know the quality of that cup. So we just put like this our mobile phone or that portable NIR device. Automatically, one software will be there which will be calculating all the parameters present in that particular product, food product. Okay, now the next slide. The NIR scanner application are becoming increasingly common in the field of estimating maturity, quality, sorting, grading, monitoring, retailing, and the research. So NIR imaging applications are more relevant at the large scale of the large and local scale. Okay, so going to the next. Okay. So here we are using some statistical tool, that is processing techniques, principal component analysis, and partial least square regression. So the data we can collect from the NIR spectroscopy are not sufficient to analyze. So for this, we need to introduce some statistical methods which are known as chemometrics. So with the help of that chemometrics, we are applying some pre-processing techniques, some principal component analysis, and some partial least square regression. Okay, now coming to the next slide. That I have already discussed. Okay, now the advantages of spectroscopy in medical. So we all know when we are having some issues, always that doctor prescribed to obtain the reports of the lipid profile or the sugar, glucose. So we are taking the blood, we are using some chemicals, and we analyze the fat content present in the blood or the glucose or the vitamin present in the blood. Okay. Now, with the NIR spectroscopy, with just a ray will come on our hand, and it will automatically, that device will calculate the glucose present in the blood. Also, for some agricultural product, we need to apply some chemical methods for the quality parameters. So I have told you earlier number of times that we can use the advantages of the NIRS to know the quality parameters of the legumes or something else. For meat and meat products as well, we can use this NIR spectrometer for quality analysis. So this is a NIR spectrum. I have told you earlier that I will show you an NIR spectrum for this. This is the NIR spectrum. So these are some peaks, you can say. You can see here. These are some peaks. This is a peak. This is a peak. This is a peak. So these are some peaks over there. So with analysis of these peaks with some statistical methods, we can have the qualitative idea of that particular product. Now, some literature. These are some literatures whosoever have worked on that particular NIR spectroscopic field for the quality evaluation of the agricultural products. In the need of NIR technology, you can see. So some agricultural products are there. So to know the quality of agricultural product, the quality of fruits present in the market, or any food product, or the growth of for growth of the agricultural industry, we can use the NIR technology. And this is a pictorial presentation of the that portable NIR device. We can have that portable NIR device. We can just put it on a sample. Let's say it's a sample S. So any sample. So the data will be collected and shown in the screen. So, okay, clear with the idea? Again, just I have written all the needs which I have discussed earlier. Okay, so I'm the last of my talk. I'm at the last of my talk. This is my research team with which we are doing a research. I am conducting my research. That is Dr. Neha Munjal. She is associate professor in the Department of Physics, Lovely Professional University. Dr. Uma Kamboj, she is the assistant professor and a leading scientist of that particular field. So she is also assistant professor in Department of Physics, Lovely Professional University. And I am Dr. Agnibha Das Majumdar. So I am doing research with the collaboration of these two people. This is my research team. So if you have any doubt on this particular topic, you can reach us with that email ID which I have mentioned here. Thank you so much. Thanks for watching.
Thank you so much for this very nice session. If any has a question, you can ask. I think no one have any questions, sir. Thank you so much, all the participants, for your activity, active participant. Let me inform to all that this complete session will be available on our research circle. Business circle. So if you want to watch to again, or want to share it somebody, please do visit the research Business Rozgar YouTube channel. Thanks. And last but not the least, thank you, Agnidas Mujumdar, sir.
Thank you, ma'am.
For taking out time for session. With your permission, I would like to end today's session here. Thank you.
Okay, thank you, ma'am. Thank you. Should I leave?
Yeah. Yes, sir.
Okay.